Hello, this is Dr. Scott Denstead, founder of the EZWxBrief progressive web app. Let's take a look at a potential severe weather threat in the southern high plains for this afternoon. So as we look at the prong charts, we see that this is valid at 18Z. So kind of right in the late morning hours where we'll start to see the possibility of severe convection showing up. This dark red area means you have severe or very likely chance of thunderstorms in this area. We do have a cold front that's kind of draped down through this region here, which is also potentially allowing some of that lifting, upward motion of the vertical motion of the atmosphere to produce convection. But you can see this red area extends over a much larger region by the time we get into the late afternoon hours here. We still see that cold front, but notice that we still have a fair amount of thunderstorms even on the cold side of the cold front, and we'll see this is due to some upper level energy that's moving through the region to help get that that air moving in that vertical direction. And we do start to see this dry line that's showing up here as well. All that is going to enhance, especially in this region here, the possibility of some strong and severe thunderstorms. Now, if we go and look at the Storm Prediction Center and see the forecast coming out of that particular organization, you'll see that the Storm Prediction Center also believes that we're going to be dealing with some pretty strong, possibly tornadic thunderstorms. This is the tornado risk. There's the wind risk here, strong straight line winds, and the possibility of even large hail in that region. So this is a slight risk, which is really on the lower side, but I really do think that in some areas they're going to see even more significant thunderstorms. So we might see this change to a moderate risk coming up, or I should say the next one here is enhanced risk, I should say. So we might see that kind of pop up in this region as the Storm Prediction Center gets a better idea and a better handle on this weather. Now, if we look at the current situation in terms of what's happening right now, you'll see that there is an area of weather here that's already started to develop. You know, it's morning time frame in this region, so not a lot of sun, not a lot of heating of the day. So we're already in a situation where we're primed for convection in northeastern New Mexico. But right now, if you look at the Storm Prediction Center's current activity, we won't see anything in terms of actually any mesoscale discussions, which would be a precursor to a severe, either a tornado watch or a severe thunderstorm watch. And right now, there's no watches in effect at this point in time. But that will change over the next few hours, where we'll start to see mesoscale discussions pop up and therefore kind of set the stage for the possibility of severe thunderstorm watches and or tornado watches, as the case may be, depending on the specific elements here. So let's take a look at the upper level flow 500 millibar chart from the GFS model, or you could look at the North American mesoscale model, or even right now the high resolution rapid refresh will also provide this, but we see a pretty potent upper level trough here. And essentially that's expected to move up toward the central plains, the central high plains, over the next few hours. It's moving pretty quickly, and it's kind of extending. We'll get the upper level charts, the higher charts in a bit, but this is 18,000 feet. You can see when it gets into the mountainous areas of Colorado up into the Four Corners regions, it does fall apart a little bit because of that. And it is in a dissipating state from that standpoint, but there's going to be a lot of activity in this region as this upper level system moves toward this region of the southern and central high plains area here. And you can even see that we have a pretty good amount of divergence. You see how these height lines fan out, so that creates a lot of divergence in this region. And also, we're also looking at the possibility of seeing a lot of moisture being pumped into this region. So the lower level, if you go down to 700 millibars, or roughly somewhere around 10,000 feet, you will see that we're going to be dealing with a good moisture-rich flow here, and it's very, very common in this area to see that. So we have our flow. You can see the wind barbs coming in off the Gulf of Mexico, and we see at 10,000 feet, the green is the relative humidity, so we're having high relative humidity in this area. And also we see this red area here, that's the omega field, which also gives indication of upward motion through 10,000 feet. And so we know that if you start the air here in, let's say, Houston or Corpus Christi, and you work your way up this way, you're going uphill. So this is what essentially, even though it's not, right up against the side of a mountain necessarily, it's still orographic lift. It's still air that's rising. And then, of course, when it hits the much higher terrain here, you have that orographic aspect of being able to get air moving upward in the vertical. And it's moisture-rich air, too, so that also drives the potential for more convection in that region. So let's go even down a little bit further. 850 millibars relative humidity. For a lot of this area, especially when we get right to the Rockies, a lot of this is even below 850 millibars. But again, 850 millibars, roughly 5,000 feet. So for a majority of the area where we're going to see that convection today in the Texas, Oklahoma Panhandle, all the way down eastern part of New Mexico and down into western Texas, you can see that all that low-level flow here is in this direction. So once again, low-level moisture being pumped in will destabilize the atmosphere and allow for some of that convection to develop as that frontal system and as that upper-level trough moves through the region. So again, it gives you a really good kind of big weather picture of what's happening there. And again, if we look at the low-level winds direction here, but when you look at a little higher level, what we see here as we go in this area here, we see the low-level winds are kind of in this direction, and the upper-level winds are in this direction. That's going to create shear in the atmosphere, which will enable the potential for tornadic-type thunderstorms. In fact, likely supercell-type thunderstorms in this region. One of the products I really like to look at to kind of set the stage for what's happening here is to look at the HREF model, which is the High Resolution Ensemble Forecast. And specifically, I want to kind of pick out and show you a couple of products. Let's look at the most unstable CAPE, the convective available potential energy. And this is from last night's run. So it's not really a lot of CAPE values are not really all that high. We're talking about maybe approaching 3,000, but this time of year you don't see as high a CAPE values, but nevertheless you still see them up there in the somewhere in the 3,000 range or near 3,000 range. So there's still a fair amount of potential for that instability, and this is the most unstable CAPE values. But if you look at the forecast radar, this really kind of gives you that perfect look at what's going to happen here. And again, this is the model run from last night. We should be seeing the next model run, the 12Z run, hit the app here probably in the next couple of hours. But watch what happens as we get into the afternoon hours. So we see this black area here is called updraft helicity, which indicates you probably have rotating supercell thunderstorms as a result of that. So anywhere you see those black areas, that's a good indication you've got that rotation. So, and that's right in that slight risk area we saw from the Storm Prediction Center. And that persists all the way through until the late afternoon and or even early evening hours as it pushes into the central part of the country. And you notice eventually that does die out by the next morning. But so I think the real threats here are going to likely be somewhere starting as late as or as early as 19 or 18Z, and then persist and also include that all the way down into a good portion of western Texas. So that's the primary dominant area we should be concerned about. If we also look at the 35,000 foot ecotops, this is a probability that ecotops may be above 35,000 feet. And so we know that any type of deep moist convection where the probabilities, these red areas, are above 35,000 feet, you got a really good indication that this is going to be some pretty serious weather in this area. It happens to be, again, from Oklahoma Panhandle down into the western Texas area, where the dominant feature is going to be. So that's, again, a product that is going to provide us with a pretty good certainty of when this is going to all develop. If you look at this, there is some stuff in the morning hours here, and we saw that already on radar, and the models pretty much picked up on that pretty well. This is from the 6Z run, so it's fairly recent. But it really starts to magnify right around, let's say, 2021Z, and that persists well into the evening hours, where it does eventually kind of peter out and die. But the time frame from late morning in this area all the way through until late afternoon will be a prime area for the possibility of significant convection. We'll take a quick read of the Storm Prediction Center's convective outlook. I don't have that specifically on my site, but I can bring that up separately. And this is the day one convective outlook for today. If we go down and read this real quick, we hopefully will see some of the same things that we saw in the EZWxBrief imagery. So it says here the water vapor imagery this morning shows a potent mid to upper level low associated with a trough moving east across Arizona. So we saw that at 500 millibars. An associated 70 knot 500 millibar wind speed max will round the base of the trough and move into central New Mexico by early evening before weakening overnight as it moves into the Texas Panhandle. We kind of saw that as well. Southerly low-level flow will maintain a fetch of reasonably rich moisture across the region today, and they reference some skew T's, specifically the 12Z Del Rio and Midland, Texas rayobs, where we're dealing with pretty high mixing ratios, which means, again, you have a lot of moisture in the atmosphere there. And then we also see that early morning surface analysis places a cold front pushing southward over the central high plains, and this boundary reached northeast New Mexico and parts of the panhandles late this afternoon, early evening. So again, very much what we saw so far. Some continuation of ongoing shower and thunderstorm activity may continue through the morning across eastern New Mexico into the Texas Panhandle, lending some uncertainty in the air mass destabilization recovery in the wake of the convection. So ultimately, this kind of provides us with an overview of what's happening with that big weather picture and how this particular area is kind of primed for that particular convection. And we can take a look at a couple of, let's go back here and we'll see if we can pick up a skew T diagram or two. So let's go to the map. And let's find let's just look at, let's say here, CVN. Let's just take and pick that as a possibility. It's Clovis. And we'll look at the skew T here for later this afternoon. And so, yeah, you can see very clearly that we have southerly winds in this area that swing around to a more southwesterly winds, and certainly the possibility of having a fair amount of Cape. This red hatched area you see here all the way through there is Cape. And we'd expect, depending on the situation, we'd expect as you get closer and closer to the afternoon kind of time frame, you may find that the Cape values, if the convection has already moved through there, it's going to stabilize pretty quickly. But right now it looks like this area, the lifted condensation level is pretty low. And so the level of free convection is really low as well here. around 7,600 feet. But we have these storms that could exist up to 43,000 feet, maybe even higher, with some overshooting tops. So for sure, we have kind of a good setup for a strong, severe thunderstorm event here in the southern high plains.